Hi, sir. Good afternoon. Saroj, sir, am I audible to you?
Yeah. Sorry.
Good afternoon.
Good afternoon. How are you?
I'm good, sir. Saroj, sir, am I audible to you?
Yeah. So the students are
Sir,
joining.
we'll just begin the session in another 5 minutes.
No issue. I was just wondering, the students are joining online, right?
Session in 5 minutes.
No issue. Joining online, right?
Yes, sir.
There is some echo going on.
Sorry, sir. There was an echo. Since we were live streaming it on YouTube, I think now it's fine.
Okay, fine. So I'm here. Whenever we are ready, we can go. Do you want me to check if I can share and the
Yes,
screen is visible?
yes.
Yeah.
I have made you the co-host for the meeting.
Okay, fine. Let me see. Can you see the slide?
Yes, sir. We can see your slide.
Oh, great.
It's in full screen as well, sir. Thank you.
Excellent. Thank you. So, Prasanji, are the students are in one place or they're joining from different places?
Sir, we have live streaming going on at various schools across. So we have a live stream done on YouTube for different schools where it is getting streamed live. Sir.
I see. But there is no way, if I ask questions, I don't expect them to be engaged, right?
Yes, that because of the school system, there is slight problem we faced, and that's why we have disabled.
Sure. Got it.
Thank you, sir. Thank you.
Yes, so we can begin the session now. I would like to welcome all of you to the afternoon session today. I hope everyone who joined the morning session enjoyed the talks by Dr. Ashok Mahapatra and also Professor from Sri Harikota. Next in line, we have with us Professor Saroj Kumar Naik, who is the professor at IIT Bhubaneswar in the School of Basic Sciences, and sir is also the Dean of Faculty and Planning at IIT Bhubaneswar. Prior to IIT Bhubaneswar, sir was a tenured full professor at Rensselaer. Sorry, sir, if I did not pronounce it right. And Sir was also a Princeton Materials Institute Junior Fellow at Princeton University. His research interests lie at the interface of physics, chemistry, engineering, with principal areas of focus on the study of atomic and electronic structures of matters using ab initio electronic structure calculation and molecular dynamics simulations. Today, Sir will be speaking on bringing sustainable technology for lives and livelihoods for billions. That is, a healthy planet gives a healthy humanity. Thank you again, sir, for joining us, and over to you, sir.
Thank you very much. Thanks, Basic ISC, for asking me to give a talk on some of the research that we're doing here and with our collaborators around the world. So I know that students are joining live from different schools. So welcome all the students. If there is an opportunity at the end of my talk, if you have any questions, I believe there is a chat box. You can also put your questions on the chat box, and hopefully we can get into the questions and answer sessions. Right. So the idea about bringing sustainable technology for the lives and livelihood for billions is something getting traction around the world. As all of us around the world going through this pandemic, we also realize how our well-being, meaning the health of humanities, how is closely related to the health of the planet. And so I hope we all, and particularly the students who are in high school or +2, who have a bright futures ahead, how they would be part of the solutions that we have to the problems that globally we are facing. Let me see that if I can go to the next slide. Yep. So this is an article and a speech also by the Secretary General UN just around the time the COVID was hitting all of us. What his message was, and this was back in 2020, so now we are almost 2 years from then, but the challenges remains same. And what he was referring to, as we know, we were all in the 2020, we were in the early part of the COVID, right? And the world that time was just bracing for the impact of the COVID-19. But he was trying to remind all of us, saying that while we were that time worried about COVID-19, and we are still worried now. But there is something else that we need to worry and find solution, right? Which is the climate change. And the climate change, it's basically it's a global warming, global heating. But as you say, global warming, sometimes the atmosphere gets cooler, and that makes public confusing, saying that, you know, how can we have cold weather when the climate is or the world is warming up? And there is a difference between, let's say, a temperature in today, tomorrow, or a temperature across a month or few years, right? So if you take the average temperature, which we'll see in next slide, what's clear, there is no ambiguity, it's very clear that the average temperature of the Earth is higher than compared to, let's say, 20 years ago, or compared to even 50 years ago, right? And as you know, the average temperature talks about even if 0.5 degree or 1 degree Celsius increase in the temperature can have catastrophic impact. And some of the things that we'll see here. But the point was that the science, and I believe most of the students joining here are the science students, but it doesn't matter in a sense because we all are human beings, we all want a healthy planet. But obviously, having science background makes it more knowledgeable into the things that we are facing. Also, it gives you the tools so that we can address the problem. So the science is very clear. As I said, if you look at the temperature over the last few years, and this is the language, if you see here, Secretary General was using, screaming to us, which means he's getting impatient, and so is many of the people who really appreciate what's the impact is going to be and what the humanity should do it. And so it's not negative, right? So obviously the problem, the climate change, the temperature increase is something to worry about. But I think it gives us also an opportunity for all of us, students, scientists, parents, politicians, everybody gives a chance for making a better world. And that's something that we'll discuss and something that we can show that even in our small little way, all of us can make a difference to this challenge and for making a better world. The approach that some of us have been seeing in the world, sometimes we think, well, maybe if we find a solution, just let's say I'm speaking from the IIT Bhubaneswar campus, right, which is in Khordha, Arugul. And if we find a solution for this community here, then I don't have to worry about the community, let's say in Uttar Pradesh. But that's not true, right? As you have seen the COVID-19, the COVID-19 first reported in China, then it quickly spreads to all the countries. So that shows that the old way of describing the world from the Indian culture point of view, which says that Vasudeva Kutumbakam, right? Which means the whole world is a family. And that's what we have seen in the COVID-19, that if we find a solution, let's say vaccine or whatever, if we just vaccinate our people or our city, it's not enough. We have to vaccinate all the people so that the virus doesn't spread. So similarly, if you look at climate change, even if we stop, let's say, using coal, which is one of the leading producer of the global warming, that doesn't mean that this climate change will go away. So the key is to find the best solution, wherever it is coming from, and make sure that we, as a community, as a global citizen, we allow all the people in the world get benefit. And that should be the way for all of us to think about. Okay. Let me qualify a little bit about the background of this climate change, right? So if you look at what I'm showing in the view graphs, this is the world population. So we are almost 7.5 billion, and that's why my title was, it's just not 100 million, 200 million, it's a billions people. And what I'm showing on the left-hand side, world populations and the year wise over the, let's say from 1200 to, let's say to 2020. You see there is something going on from 1800 to 2000, and that's basically the includes the industrial revolutions, and which is where the energy consumption, right, by humanities increased dramatically because of the industrial revolutions. Earlier, people used to do everything by hand, right? And then with industrial revolutions, we had rail, we had machine, we had electricity, we had all those things needs energy, right? I'm talking to you with my laptops. You have been visualizing with your laptop or with your desktop. We have switched on the light so that you can see me better. So all of these things, they use energy. And in the year from when the industrial revolution started up until now, right? The energy is consumed by modern humans or modern lifestyle. And this energy is primarily from fossil fuels, right? This is, smoke and steam coming from Europe's largest coal plant. But, yeah, if you are in Odisha, if you go to Talcher or if you live in Talcher, you know that, the coal plants there, which provides the electricity to all of us in Odisha and beyond Odisha, uses coal. And the coal will give rise to smokes, dust particles, and it pollutes. In addition to that, it gives rise to CO2, which is called the greenhouse effect. Basically, it absorbs the heat compared to without CO2, which the heat would have been gone. As a result, the temperature increases, right? And so if you look at from over the last 10 years or so, the CO2 emission in the world continuously has been increasing. Okay, and this is because initially the energy consumption in the Western world was very high. If you want to talk about per person or per family energy consumption, the Western world is much higher compared to the, let's say, let's say Asia, compared to India, for example, 20 years ago. But as we develop, and as India is developing, China is developing, many other countries are developing, and rightly so, they will all use again more energy. In fact, if you look at the energy consumption per family, and if you look at the development index, which means the country which is more developed, they usually typically use more energy. But the problem, so there is nothing wrong to be developed. There is nothing wrong to use energy, right? But the problem is the energy consumption that we are having is mostly from coal, oil, gas. All those things gives rise to carbon dioxide and other gases, which are known as the greenhouse gases, which means they really help increasing the temperature of the earth. And as the temperature increases, we'll see the impact it's having, and this is what the climate change is considered a challenge now, and we'll talk about that. But I'm showing here, again, as I said, because of this energy consumption, you can see the temperature increase, particularly if you look at, for example, over the last 60, 70 years, is dramatic, right? And you say that, well, 1 degree Celsius is nothing, because I have today 30 degree, tomorrow I can have 31 degrees. So what's the problem? Well, the problem is that this is the average temperature. In certain part, you can get 4 degree, 5 degree above the normal temperature, and that's quite a bit. And average 1 degree temperature can have a catastrophic effect, right? Such as, for example, I'll show you the melting of the ice in the Arctic. So once the 1 degree temperature or a few degree temperature can start melting of ice in the poles, they give rise to huge cascade effect, which means that melting ice there increases the water level, let's say in Bangladesh. So over the last 10 years, you'll see some of the areas in Bangladesh, they're submerged with water, so no roads. So if you want to go one place to another place, you have to go by boats, right? And the similar things is going to happen in many coastal areas if we do not stop further increase of the temperature. In fact, it's agreed by scientists that unless we restrict the temperature to 1.5 degree above the pre-industrial temperature range, which means if I go back, right? Here is the what? The pre-industrial temperature is, let's say, we call 0. We already have 1 degree, right? We can maximum allow another 0.5 degree. And as you can see, if the way we are using right now, energy, for example, most of the energy now in India, for example, is coming from coal. I think that's about 60% energy is coming from coal. And we are trying to reduce that dependence to much less, so that the global warming can be the acceleration can be stopped, right? And as you know, all the countries have pledged, and India also has pledged, so that the energy consumption that we are having right now from coal will be decreased. To be fair, actually, country like India, they use less energy per person or per family compared to countries like US. But as I said earlier, it doesn't matter whether US produces more CO2 or China produces more CO2 or India produces more CO2. We are all together in one boat, that is the world, and that's the earth, right? And so it is responsibility for all of us, all the countries, to make sure that we do not go beyond 1.5 degree Celsius above the pre-industrial temperature. And how will that happen? As I said, the way we are using right now, that's not the solution, because we mean India, China, US, many other countries, that they're using more fossil fuel than they should use. So the solution is, as scientists, as the board, the future scientists, all of you, is to find sustainable technology, sustainable energy, and some of the things that we'll be talking about, some of the things we may not be knowing right now, for instance, and you will be the people who will discover those technology, who will be the savior for the world, not to increase to the point that we can't return back, right? So as I said, this is not scaring you, right? Saying that was all negative, the world will come to an end, nothing like that. But as a scientist, as an engineers, as a technologist, we should know the facts, and we should also find out the solution, right? It's like COVID-19. Imagine if you didn't have vaccine. With the vaccine also, unfortunately, some people had to be hospitalized, some people died. But imagine if you didn't have the vaccine. So the similar things, the global average temperature has to be restricted, not going beyond, let's say, 1.5 degrees Celsius compared to the pre-industrial revolutions. So which means we have to find solution. We have to find the vaccine-like solutions for this climate change or global warming or global heating or whatever you call. And frankly, the students like you all over the world are leading to fight this climate emergency, right? And in fact, I think our generation and generation before us, knowingly or unknowingly, used fossil fuel. So we are the responsible for creating this mess. But as I said, it's no point in blaming anybody at this point. And the solution has to come from all the fronts. And that's why the problem, and as you and General spoke, it's much bigger problem than what we are seeing in COVID-19. COVID-19 itself is a big problem, but the climate change is much bigger problem, and we all have to come together. We all have to find a solution for that. So I'll tell you, you can ask me, for example, well, you are, Dr. Nayak, you have been speaking, but you are also scientists. What did you do to help us, to help find solution for this one? And fortunately, for example, as ma'am was saying that, I came back to India 6 years ago. I was a professor at Rensselaer. If you don't know what Rensselaer is, it's called Rensselaer RPI. If you are science students, you must be taking a book in physics, Resnick, Halliday Resnick. And Resnick used to be a professor, in fact, in the same department that I was a professor at RPI. And so when I came back 6 years ago to IIT Bhubaneswar, we formed a center of excellence on energy. And this was supported by Ministry of Education now. And since the problem is so big, not a single person can find the solution. Not a single institute may be finding a solution. And as you will see in a couple of examples that we'll be showing here, collaborative approach, interdisciplinary approach, where scientists or physicists talk to chemists, chemists talk to material scientists talk to biologists, and all of them talk to each other. And it's across the institute, not just IIT Bhubaneswar. We have an Institute of Physics. We also have a Rice University in the US. We also have to talk to industry, right? As you know, we as a scientist and engineers, in academics in a university, we do fundamental research, right? We also work with industry who can take the solution, and sometimes we ourselves also can start startup. As a student, as a professor, you can start your own startup, getting some of the idea, testing in the ground, and we'll show you one such example that we have also done here. And as I said, the problem of finding sustainable energy had many fold. For example, what are the sustainable energy? And we'll talk about few sustainable energy solutions, but there are many, right? So one is the solar. For example, we know sun comes every day. So it gives enormous amount of energy, right? In fact, is so much energy sun gives us as its science that fraction of that will be enough for the entire world needs. Then you say that, sir, then solution is done. We can always capture the solar energy, and since fraction of the solar energy that's coming to the earth will be sufficient for world's need, what's the problem? Well, the problem are manifold. First, this energy comes, then you have to convert and utilize the way we can produce electricity. And that's what you know that it's called photovoltaics is one technology where solar cells like silicon or new organic materials. So when the light falls on them, so then it's it can excite the electrons, which are the carriers, and then the carriers can give rise to electricity. But then in the night, sun is not there. So what do? You switch off everything and then say that, okay, when the sun comes tomorrow, I'll use it. That doesn't work. So you have to have something called storage system, like a battery or supercapacitor or some other technology like hydrogen fuel cell and so on and so forth. You will be learning. If you have not learned so far, don't worry. But what these are the technology, or these are the energy storage that we call. We collect in the morning, then we store for either rainy days or for in the night. But the point is that it can be very costly. Storage can last only few hours to maybe few days, and let's say some area you may not be able to get sun, for example, right? In certain countries, for example, you get a very less sun, or in certain parts or in certain seasons, for example, you get very less sun. For example, in monsoon in India, you get very less sun. So you can't store today for next few months because battery discharge happens. So there are challenges, right? So this is where new science can be done, new technology can be done. Even if we have the technology, and in fact, we have some technology that we can store for months, but it costs very, or it costs the cost of storing is quite large, right? So those are the challenges that we need to address, and we need to find the solutions. Okay, so again, fortunately, we work around the globes, around, as I said, with different countries, different groups, and some of the things that we have done over the years has been recognized by experts. And this is something that you should keep in mind. It's not just, you should not take whatever I'm saying granted. You can challenge my thoughts. You can challenge by discussing with experts. So always respect the people, experts in that field, and the experts cannot be just a one single person, right? So what I'm trying to tell that, you know, even if we claim that we have done some good science, some of the new technology, is the experts which tells us in terms of, let's say, reviewing the paper, in terms of recognizing our technology and using it, and that justifies that that sometimes, you know, confirms that this is a world-class technology which can be replicated in different parts of the world, right? And we'll show you that some of the things that has been done in that way. Another point before I wanted to show some of the solutions is that there is a nexus between energy, food, and water. Okay, so as I pointed out, the climate change and energy, but they're also related to agriculture, which basically is food and water. And as you can see, you don't have to be a scientist. You don't have to be even close to science students to recognize this. Even our farmers who have not gone to college or school, they know how important is agriculture with water. And in the modern agriculture, how important is that to the energy. Even the smallest farmers needs water, and it needs the water, typically gets the water to the agriculture through pumping. And pumping uses a lot of diesel. Unfortunately, again, diesel is not a good for environment. So you have to have something more sustainable or more renewable energy like solar. And we'll show that some of the technology that we have developed along that line. But this nexus, what do we call FEW, food, energy, water, is very important. And in fact, it's quite important in finding the solutions for sustainable practices for our world. Okay, and there is a good book by Sarah Best. It talks about you know, how do you do large electric, particularly rural electrification in a country like India, where you can provide sustainable technology, right? As you know, in India, more than 70% people live in India in villages, and which is a good thing, right? I mean, the village has, I mean, some of you, if you live in villages, you know that the air is very clean, it's very green, but it also has its own challenges, right? The electricity is not, or at least it's not used to be dependable. And so how do you find solution? Even if you provide electricity, as we have been saying, if you give the electricity to all the people, then you'll use more coal. But that doesn't mean that you should not give electricity to all the people, because I have the electricity. So you said, okay, the other people should not use electricity. That's not a good way to find the solution. So rather, we should find a sustainable way to provide energy to each houses, for example, right? And of course, food is essential for all the human being. So as you do this agriculture, but you should also practice sustainable in terms of the energy, in terms of the water uses, for example. We'll show you in some of the study that we have done that water is going to be another crisis. And again, we call climate change, but water should be part of that solution. And again, the challenge only happens when we are not mindful of using it. As you know, humankind has been there for last thousands years. Why this problem is coming, in my opinion, is that we are not mindful about the use of energy or food or water. Because of the excess use of energy, excess use of water, we have all this crisis. And so sustainable solution is a part of that that philosophy that you can't use excess, because it's just not our generation or your generation. So generations to come, there is a saying that it's always better to give something better than what you have achieved from your previous generation. So with that focus, it's important for each generations to make a world better for the next generation. Okay, so the water crisis has been seen. This is a photograph from a few years ago. Chennai water crisis, how people carry water, and unfortunately still exists in some part of the world that people have to travel few kilometers to get water. In Africa and in other countries, that is still becoming a challenge. And in our countries, some of the states, for example, because of over exploitation of water, the water depth or water availability is depleting. So I think we have to also be mindful about that as well. So as I said, through our research, through the collaborations, we have found some of the solutions for addressing these problems. But again, we need more solutions. We need more ideas. We need people like you to join this challenge and provide opportunity, right? So, but I will describe two innovations that we have done through research. And we have a startup from IIT Bhubaneswar, which is name is Kalinga Renewable Energy, or Karma. And if you look at one of the problems that I mentioned, is agriculture, water, and energy, or few, right? Food, energy, water. And about 60% of Indians live or their livelihoods depends on agriculture. Okay, and pumping is one of the way we extract, the farmers extract water from the ground for their cultivations. And when we looked into this research problems, why not all the farmers able to use solar pump? Because as I said, in the solar pump, you use solar panel, which we'll show in a moment. And once the sun comes, it shines on the solar panel, it produces electricity, and the motor runs, and you give water, you get the water, or you extract the water. So as simple as it is. Then why all the farmers are not using it? Well, the first thing is that it's very expensive. Okay, so this is where we wanted to do research. To make the story short, what we found that Indian farmers, typical Indian farmers, have less than 2 acres of land for cultivation. If you look at European Union farmers, US farmers, European Union farmers typically have 10 acres minimum. US, where I spent about 20 years, typically the farmers have 100 acres land or more. So they need bigger pumps, whereas our farmers, the way we do cultivations, and it has its own strength, we don't need large pumps which cost quite a bit of money. But there was no pump, small pump, or what we call a micro pump available. So we did research in collaboration with one of the good company which makes motor, which is Kirloskar. We introduced the first solar micro pump in India that is certified by Ministry of New and Renewable Energy, which certifies that you have a pump with, let's say, whatever your claim is, giving water with minimal panel and so on and so forth. So this is the technology we brought. It can pump water for irrigations, for drinking water. In fact, it can combine with water to give you purified water through solar powered UV technology. And these are the different installations. These are the solar panels. In fact, this was earlier version. Now the technology, this is what I wanted to tell you, that you have to always research to improve the products, to talk to people who actually use in the ground, right? and then come back to the lab and do the research to improve the products. So when we initially 5 years ago, we started, we had 5 panels to give this water, but farmers told that they want this to be moved from one place to another place so that they can maximize their utility. Sometimes they said, theft can be happen, so they want to take home. 5 panel will be difficult. So again, through research, we could find that 3 panels can do it and can move from one place to another place so that many farmers can utilize, right? This is kind of a Ola or Uber. You need to go from one place to another place in a car because there is a rent, there is a safety, but you don't have to have your car all the time parking in your office because you don't want to either you don't want to buy it or you don't want to only utilize this one. So that's why Uber and Ola is quite helpful. The same thing happens, for example, if you can move from one place to another place through even cycle trolley or even using some of the things that we have done in Uttar Pradesh, where tractor can take this panel from one place to another place. But the point is that through research, you can find some of the sustainable way of doing it. I'll try to run a video to see. Can you see the video? Anybody can speak? Whoever can see the video.
Yes, sir. We can see the video.
Okay, thank you. So this is the video. This is the collaborations between IIT Bhubaneswar, Karma, MIT, and another startup from Flissum from Switzerland. And this uses the state-of-the-art, flexible and rollable solar panel. The panel that you saw earlier, it was silicon panel, very heavy. Even if you can tell from trolley, it's difficult sometimes. But this is the panel that you see lying on the grass. You can roll it up like a paper. It's very lightweight. It's like 2 kg, and it gives huge water go from one place to another place. For example, right, as you can see here, for example, either you can extract the water as we showed earlier from a bore well, dog well, or from river, and then you see that the panel is even the small child can take, roll it up, pack it, go from another place to one place to another place. And this is, as I said, done in collaboration with MIT US and Flissum and Karma and IIT Bhubaneswar. This model now is being adopted by UN in Sudan. And one advantage of this model is that farmers don't have to buy. They can just rent, okay? So again, the point is that the technology, the science, the research, they all had to be kind of merged together so that you can find the solutions. If we didn't talk to the farmers, if we didn't go to the site, if we didn't understand their problem, I don't think we would have found this kind of solutions. If we didn't collaborate with MIT, if we didn't collaborate with Flissum, if we didn't have a startup which takes the technology from the lab to the land, I don't think we would have found the solution. So the message what I wanted to give you is that we need ecosystems. And frankly speaking, the credit also goes as much to the farmers who demanded this. Otherwise, how will know what do they need? And similarly, if we didn't collaborate with Flissum, who's sitting in the Switzerland, to have this technology, to listen to us, to find out, because again, there are many technical things I'm just skipping. You just can't go to a panel store and buy it and it will work, because we wanted to make it most efficient. We want to make it most affordable, but not cheap. Because affordable, there is a difference between affordable and cheap. Cheap is not good, but affordable is something sustainable. So that's what we should be, or we could do it because of this ecosystem, because of the collaboration between different institutes. Okay, and this we have done with a tractor, also with the bigger panels and heavy panels, and this is in UP. So I'll skip that because the message is very similar to what So what is saying that what is saying that you can go from one place to another place and utilize this technology, right? So just not irrigations. This we also have to find solutions. For example, for basic street lights. In fact, when the COVID came, we are approached by one organizations in Raigada saying that some of the students, they were either in Delhi, IIT, or Delhi University, or they come back home, online classes started, they don't have electricity, so how can they attend online lectures? So we call digital educations, and we provided them even in the mountains and terrains. These are the integrated ones, which means on the top that you see is a panel. In the bottom that you see here, lights, and they have sensors, so you don't have to switch it on and on. It will be switched off when the sun goes away. And this is the lithium-ion battery. That's the state-of-the-art technology, and or it automatically switches off when the sun comes in the daytime. So it stores the energy for utilizing in the night. It has camera, so that it provides safety in and around, let's say, the villages, right? So similarly, again, this is called the aerator. I'm just telling you the different technology can become sustainable. This is all powered with the solar. This can be utilized for fish farming, but this can be also utilized in cleaning water, which otherwise will grow some of the algae and other things, which is not necessarily good for clean water. So the point again is that you listen to the need of the ground, at the ground or in the land, and then you bring the technology, again, affordable but not cheap, and you bring the state-of-the-art technology. And the things that as we speak, as we are doing, as I showed you, the lithium battery, but our lab and across the world also, we are working on some alternative technology, like, for example, zinc battery or aluminum battery. And you can ask why? Because lithium is expensive, and with the geopolitical tension, lithium is accumulated in only certain countries. Whereas if you look at aluminum, India is a leading producer of aluminum. Okay, and then you can use this technology in a cheaper way. And other thing we should keep in mind, it should be sustainable, right? So how you can make sustainable if you don't recycle it? So lithium, unfortunately, till now is not, you don't have a roadmap for recycle. But whereas aluminum is a very mature technology, which has a huge more than 90% of aluminum right now gets to recycle. So if you use aluminum battery, and there are challenges, but we and others are working on making aluminum batteries affordable, as I said, and scalable, and definitely this will be sustainable, because aluminum is completely, right now the technology is available where complete aluminum can be recycled, so that it can make a circular economy for battery. You start from aluminum, use it as a battery, then comes back again, reuse it. So that is another technology we have been working on. Hopefully that will be also integrated to some of the products that we have developed through startup, through collaboration, and so on. Okay, so yeah, so not just the aerator, but some of the processing unit, for example, right? So for particularly in the rural areas, people either depend on kerosene or diesel or electricity, but electricity is not very dependable in the rural areas. So that's why we are bringing the technology where you can integrate the solar, and then all the processing units, cold storage, everything can be integrated to the solar, so that you can find or provide a complete solutions, all the way from giving water to the crops and food processing and storing in terms of cold storage and so on and so forth. Okay, so I think of course other technologists, other companies, and we have been using this rooftop, so that as I speak here, for example, or if you are in the kit or in other part of the India, you may have already solar rooftop that you don't know, which means right now some of the energy that I use is coming from the solar. And so, which means not 100% I am using CO2 or fossil fuel based energy, and that's a good thing. So the more people we use a mixture of, let's say, fossil fuel, because in the night we might be not have enough battery to store, but at least in the daytime we can use solar, for example. And solar is now affordable. In fact, over the last 2 years, not just in India, across the globe, more solars are installed compared to the number of coal plant that has been established. But unfortunately, there are so many coal plants that we have installed. We means the whole world has installed over the last 50, 60 years. We really all have to gear up. We all have to find novel solutions so that the coal can be stopped burning, and more sustainable technology like solar, wind, of course, hydro. All these things can come and part of the energy solution. The problem has been that we are depending too much on coal. It's not just coal. I mean, CO2 is also required in atmosphere. The plants take CO2, for example, but we have been using excess of CO2. This is what in the beginning I told you, right? So as long as we have a mixer balance of coal, renewable, solar, wind, nuclear is also some of the countries are pushing through, which doesn't provide pollutions, but there are other challenges in nuclear technology, so I'll not go into that. But at least some of the things people agree, like solar, wind, hydro, all of them constitute what's a part of the energy solutions. But as I said, we have more miles to go. All of us need to work on this one, do research, bring the technology, and make a healthy planet. And these are the things we also involve even the primary school students to assemble some of the solar products. And this has done it with many companies like Vedanta, Nalco, NCL, Power Financial Corporations of India, where they provide funding. We involve school children's, neighborhoods, communities. They assemble with our technology. They provide the lights because some of them live off the grid. The grid cannot reach there because of the terrains. So, but we don't want them to be without light. Light is necessary for studying, for doing work, for safety from animals and having comfort. So as long as you provide them, they take care of those things. Nothing like that. So this is also we work with them. And finally, I think something that we all know that it is very important. All of us, students, elderly, middle-aged people, we all need to get engaged in a constructive way. So which means providing good quality jobs and sustainable technology. It has been studied by many agencies, particularly International Renewable Energy Agency, which is a very highly respected agency. And they show that if you use this science and technology, you create very good quality jobs, not hazardous job, very good quality jobs. So that is also again a part of the solutions, that you focus on sustainability to lives and livelihood of billions, not just the lives to provide the quality of lives, but also livelihoods. Okay, and what's the best way to teach them, particularly the young generation, as compared to, for example, teaching them through activities? And this is something that I hope that all of you would get excited and to be part of. Doesn't matter where you are, doesn't matter which lab you go, But hopefully you all can be part of the solutions in the future. So with that, I think, as I said, this is not a crisis that we have to worry about without finding the solution. This provides, in fact, a opportunity, and not worrying about is not good, because that doesn't give you a good, duty for you, right? And of course, and excellence on anything that you do is really sustainable. So with that, I'll stop it here. And if you have any questions, we'll be happy to answer. Thank you so much.
Thank you, sir. Thank you for the wonderful presentation, for inspiring school children to giving an overview of the latest technologies about the startups and how it is solving actually societal problems and real world issues. Sir, next, if with your due permission, there are a few questions in the chat box. Should I read them out?
Yeah, I think if I'm able to read it here, it says that please discuss also about the solutions which is leads to healthy planet. And I think we have talked about some of the solutions that leads to the healthy planet. For example, providing maybe this question came before I gave this some of the solutions. But yeah, we need solutions. For example, having high efficient solar panel, good battery which can get recycled at the end of its life cycle, but it provides solutions for sustainable energy. But I think the second question, I think, what's the price of the half HP devices? I mean, I think it's about 50,000 rupees, including everything, so the panel, pumps, and everything. So I think, but that you can talk to various, not just the startup. Of course, you can write to the startup, but I think we introduced this in India, but now other companies are also, based on our technical specification, they are making it. But I think the price is around 50,000 rupees. What's the life cycle of solar photovoltaic system, and what is the recycle scenario in India? That's a very good questions again. I think lifespan now is about 27 years. So each panel that you take it today, it lasts for about 27 years. I think the recycling scenario in India, I think the government is going to, so let me address this question. That's a very important question again. As I said, you just don't make a product and then after 25 years, it's going to come and haunt you saying that it's not good for the environment. But fortunately, if you look at Europe and US, they have gone through this little earlier than a country like India in terms of the use of photovoltaics, and they have a very good policy for recycling. So I think India needs that, and I think my understanding is that India is going to have a recycling policy very soon, which means, and I'll tell you what are the solutions typically happens in abroad. So if a company makes a panel, then that company is responsible for making it a recycle. So which means that if you buy a panel from today from some company, and government has a policy to track it down. So people questions what happens that company disappears. Well, if that happens, government takes tax, and that puts the tax of recycling in some account, so that government, if the company goes bankrupt, government does that. But typically big companies don't go that far. So they all have responsibility and they pass on this one. I think India is going to have a very strong recycling policy very soon for the solar panels. And since other countries have already gone through this problem, it's a good for us that we can follow basically what they have gone through. So yeah, I think these are the three questions that I see it. But if you see any other questions, you let me know.
I would request the audience that if there are any other questions.
One question from my side. I am Sudhir here from VCKIC. Sir, wanted to understand, you have shown that example of foldable flexi solar voltaic panel. Do we see a short-term commercial scale production in India? Because other than US and Switzerland, I only see CSIRO of Australia doing a research on flexi printing technology, basically, which you have shown. So do we see something similar in commercial scale in India in soon?
Yeah, again, an excellent question. In fact, there is a startup from Stanford. We and them have long discussion, and to make the short answer is yes, and the long answer is that you need minimum, minimum market size before it is able to manufacture in India. But the good part is that unlike silicon, which takes huge amount of money for starting, this foldable is much less. So I think the price is on this side, and as you rightly pointed out, only 3 countries are now doing it. I think once the market goes to a small number, not huge number as much as in silicon, just small number, you'll see a lot of people will be interested to manufacture in India.
And one add-on to that, the ink, because as you said rightly, recycling of photovoltaic, this bio-sourced inks, which have shown promising research of late. Do we see a research in India happening in that segment as well in our institutions? Because you will be the right person to understand.
Sorry, I missed your questions initially. Which topic?
The bio-sourced, the inks produced from the biological source, extracted from biological source. The photovoltaic ink.
Yeah, sure. I think again, excellent questions. Unfortunately, you are right that Indian groups have not started on the research on that direction as much as I would like to, or you would like to see it. But I think this is again a research that India should get into early on. And the same story goes for the bio-inspired hydrogen, for example. As you can see in in the recent past, the hydrogen is getting quite a bit of traction. But what's missing again there is the bio-inspired hydrogen cell, for example. So the answer is, yeah, unfortunately, it has not happened, but it should happen more than what is happening right now.
Thank you for the wonderful answers, sir. And I am sure that future research, most of the students would take the cue from this going forward and understanding this space in broader perspective. Yes, implementation have happened in India in a very greater scale, and now the thirst is very high. And now the diversification and sustainability is the core for the research team, what we believe in. Thank you a lot for the wonderful session, sir. And on behalf of BCKIC, we thank you for your time spared. And thanks again from the BCKIC and the entire Vigyan Week, Science Week, which we are celebrating in India. It is because of you researchers that we always feel pride in. Thanks again, sir.
Well, thank you very much for doing this. Really, it's a very appreciable what you have been doing and the way you have been linking all the stakeholders. So really appreciate that. Thank you so much.
Thank you, sir.
Thank you, sir. Thank you, sir, for the wonderful presentation and also for patiently taking time to answer all of the questions that were posted. Thank you again, sir. For the next session, we have Dr. Prashant Sahu. He's also from IIT Bhubaneswar. But before that, we'll take a short break of 3 to 4 minutes and then begin with the next session. Hi, everyone. I welcome all of you back to the fourth session of the day, which will be delivered by Dr. Prashant Sahu. Welcome, sir. Am I audible to you?
Good afternoon. Yeah, it's audible.
Just a minute, I'll make you the co-host, sir. Yes, done, sir. You can now share your screen. Meanwhile, I will give Sir's introduction. So, Dr. Sahu is currently working as an associate professor at the School of Electrical Sciences in IIT Bhubaneswar. He was the former head in the School of Electrical. He was the former chairman in Computer and Information Technology Services Cell CITSC of IIT Bhubaneswar. He did his BSc honors in electronics and telecommunication engineering in the year 2000, and then he post that he did his MTech and PhD from IIT Kharagpur in electronics and electrical communication with a specialization in fiber optics and light wave engineering. He has also worked in the University of Scala Superiore, Sant'Anna, Italy. Sorry, sir, for if I misspelled it. For a year in the field of signal processing in distributed sensor design. Sir's research focus area is in communication engineering, fiber optical communication, and fiber sensor. Today, Sir will be speaking on augmented virtual reality, opportunities and challenges. So without any further delay, I will request Sir to kindly take over the session. Over to you, Sir.
Thank you. Thank you, madam. Good afternoon to all. My screen is visible.
Yes, sir, your screen is visible. If possible, please, if you could do it in full screen. So yes, sir, it is in full screen now.
Okay,
Thank
fine.
you, sir.
So first of all, let me thanks Professor Prasant Singh and Lakshman Padiji for giving me this opportunity to speak during the Science Week. So today I'm going to speak about virtual and augmented realities, opportunities and challenges. So as all of us knows that the technology changes over the years. So right now we are hearing about the Web 3.0. So we are in an age of internet whereby we are on Web 2.0. Now people are speaking about Web 3.0. So the point at which we are discussing about this Web 3.0, this virtual and augmented reality looks like a very promising area. So with this virtual and augmented realities, so what are the possibilities? So what are the application areas? What are the challenges that we are going to face? So today I'm going to describe on that. So my today's presentation layout would be something like, I would like to speak about a bit on these two technologies, virtual reality and augmented realities. That will be fall under this introductions. Then I will say a bit more on to augmented reality and the virtual realities. And then I will list out what are the current research activities that we are working at IIT Bhubaneswar in this area. And then I will say what are the possibilities that we can look for this AR and VR. And finally, I will complete my talk with the conclusion. So let me start with the intro part of this augmented and virtual reality. So if you have any queries, you can ask me. I'll be happy to answer. So when you say about this augmented reality, how it evolves, basically this augmented reality evolved from a laboratory experiment, and then it has been explored for the military and then for the industrial applications. So now at this point, researchers are working on a mass scale implementation of this augmented realities. So when I say about augmented reality, so the word itself refers that we are adding on something to the physical world. So what is that additions? So that we need to know. How do we create a augmented reality scenarios? So that is a challenge. So we will see how people are working on that. So what are the ways by which we can add on, or you can say we can augment some digital technology on the physical world. So that's about the augmented reality. There is a misconception that whenever somebody say about augmented reality, people think that, oh, well, this is about a visualization technique. So whereby we can get some directions or we can get a feel of visualization of the products. But augmented reality is more than that. So if you see, the current trend is how to integrate the different kinds of sensor onto this augmented reality platform. So by which we can have not only augment the digital technology to the physical world, but also we should able to exploit this digital technology for the benefit of the mankind. So this is what the major objective behind this massive interest for this augmented reality. So if you see, this augmented reality again starts with a kind of say thinking. So in 1956, this is the Philip K. Dick who wrote this Minority Report and created a reality of augmented reality. So whereby the information literally was available at the finger points. So this is a kind of say a thinking in the year 1956, whereby he has written a report whereby the assumption is what, how we can get the info at the fingertips, how do we augment, how do we have a concept for augmenting the real world with a digital world. So that was formulated around 1956. And this augmented reality, if you see, if you look back to the history, the same year around 1958, the head mount devices were invented. At that point, the idea was how to provide a immersive feelings or a immersive technology by which people can have exposed to different kinds of entertainments. So this is a very long-standing technology from 1958 onwards, but the major interest rises over the last 5 to 6 years back. It started in a mass scale. People are trying to explore this augmented reality platform into different domains. As I referred in the very first slide that we are going towards Web 3.0. So when I say that, you can think then how it is related to this AR VR. So basically, when you say the internet technology, we know that it is basically an interconnection between different networks. So that was Web 2.0. So whereby the idea is to have a central server and to access the info from a centrally located place. But in Web 3.0, the idea is to make it decentralized. Many of you must have heard about this DAOs, decentralized autonomous organizations. So this is where this Web 3.0 will be used. In the same way, if you see the augmented reality, now this augmented reality has got many platforms and people are planning to merge all these platforms plus the synchronous mode of communication onto a service, what we call as metaverse. So we can say the success or failure of metaverse is highly depends on this AR and VR technology plus the synchronous communication. So this too will decide the future of this metaverse. So metaverse is a very recent topic of interest. So many of you must have heard that this Facebook has ventured into this metaverse. Similarly, some other big companies are now jumping into metaverse. So the future of metaverse basically relies on this AR, VR, plus the synchronous communication. So AR, VR has got a huge futures, or you can say huge plans to penetrate into the social life of the human society, just like the smartphone is now an integral part of our day-to-day activities, you'll see that this AR/VR applications also will be a integral part of our activities in the next few years. So in this sense, I can say that this wearable augmented reality displays, which overlays the virtual data and images into the real world, combines with the new operating systems, will enables a new kind of spatial computing, which will in turn demands new user interfaces. So here you can see this particular statement. This gives an idea that so this AR can open up a new area of research, or you can say the opportunities for the jobs, for the research and development, and also for commercializations. And that's in terms of the spatial computings, as well as the interface designs and the displays. So these are the some of the possibilities or the opportunities that AR can open up. But at the same time, if you see the AR systems, these are highly or extremely complicated and complex to realize. The major challenge here is that we need to add on some additional features for this wearable augmented devices, like it has to be lightweight, it has to be portable, it has to have a very low key factor or form factors, and it has to be affordable. Then only it is possible that a mass adoption of this technology will be possible. So these are the areas where we can work on. We can try to solve some of the issues related to the mass scale realization of augmented reality. So after giving a very brief on augmented reality, I will like to say something on virtual reality. So in the augmented reality, as I said, the user is having a connection with the real world, whereby we are trying to augment your real world with the digital technology. But when I say about a virtual reality, here the objective is to create a separate reality where the user will be away from the physical world. So I can say that this virtual reality is a technology where the VR device, the virtual reality devices, will create a new reality from the scratch and bring the device user to a new reality while almost cutting the user from the real world. So you can say the person is no more in touch with the real world, rather the system will now control the person. So whereby the VR devices will play a role, so which will have a number of sensors, a number of display technologies, the trackers. So this will control the user. So I can say that now the user is no more in direct in contact with the physical world, rather he is immersed in a new reality, so which is being produced by means of this VR devices. So I can say that when I compare this VR with AR, this augmented reality is a technology where the AR device, which may be in the form of a smartphone or a PDA or a tablet, it's create a new reality by adding on the digital aspect into the real world. So you can say that here the user is not cut from the real world, rather he is in sync with the real world. So depending on the requirement, one can design the virtual reality based applications or the augmented reality based applications. So this two are two different aspects. In one case, as I said, the user has no contact with the physical world, whereas in the other case, the user is in touch with the physical world, where the physical world is augmented or is being added with a digital content. So now if you see this figure, so here I try to explain the augmented reality devices in different applications. So the application can be classified into three broad categories: consumer segment, the commercial segments, and the industrial or the scientific segments. So the activities, if you see, it may be the passive activities or interactive activities. And then the viewers, where you have the visualization scenarios. So for that, the options are, we can have the GPDs, the general purpose devices, or we may have the IDs, the integrated and the dedicated devices. Like the examples are for the integrated and dedicated devices are a smart glass or the helmets, the head mount devices, what you can say. And similarly for the GPDs, the general purpose devices, which can be used as the visualization unit for this AR applications, maybe your smartphones, the tablets, the PCs, the TVs, or the PDS, or maybe the tablets, and so on. So you can see one of the typical arrangement of a smart glass, which was proposed by the Steve Mann. So when he proposed, he has something in his mind. So what is being shown in this figure, so you can see, so he assumed that a wearable glass may have these features like, where are you going and looking for? So what are you looking at? What's being heard? What's being displayed? What are you doing and how you are doing? Data transfer and communication from the wearable glass itself, and the system supports like the storage. So now if you see all this, what he proposed in a glass, which is now feasible today. So what he said about where are we or where are you? So that can be possible to know from this wearable glass by exploiting the use of this GPS or the cell towers. When he said about where you are going and looking, so that can be incorporated into the smart glasses by means of a number of sensors like the IMUs, inertial measurement units, the accelerometers, the gyroscopes, barometric sensors, the depth sensors, or the front-facing cameras. So the tasks where you are going and looking can be achieved by integrating this kind of sensor onto this simple smart glass. Similarly, the other requirement, what he said about what are you looking at, so which can be done or realized by means of this eye tracking cameras. What's being heard? So this can be implemented into the smart glass by means of incorporating 2 or more microphones for directional focus and noise cancellations. The next assumption was what's being displayed. So this can be realized by means of high resolution, high refresh rate, and HD sensors, like you can say the ambient light sensors, wide field of view, correct convergence focal planes, the lenses. What are you doing and how you are doing? So these activities can be realized on a smart glass by means of this biosensors. And the other assumption by Steve Mann was data transfer and communications. Well, this is quite easy to implement these days by means of this Bluetooth, Wi-Fi, Zigbee, or even USB-C cables using, or by means of this 5G technology. One of his assumption was the storage, the system supports. So the local storage and the batteries, so power supply from the inbuilt battery source, and also all the sensors data can be locally stored by means of a micro SSD card. So this is what it was his assumptions. Now you can see that all these features can be realized by means of a smart glass. So this is what I shown in this figure. So the assumptions what he thought of for a smart glass, it is now possible today with the invention of so many kinds of sensors, all the activities that we can think can be incorporated into a simple plain glass, eyeglass, and which can be then treated as a smart glass. So this is what is a requirement for your this AR VR implementations, which can be easily designed as is shown here. Just 1 minute. Fine. So once we heard about this possibility of converting a ordinary eyeglass into a smart glass, then the curiosity arises. So what more is required for this AR VR purpose? You can say the systems that we need for realizing this AR VR applications. And then what are the major commercially available products that are there, and what are the challenges, and how we can make the system lightweight, compact, small form factors, requiring less power, at the same time capable of transferring the info, maybe on a wide or a wireless manner, and so on. So all this question come into mind. So I can say that, let me start one by one for this. Start with the virtual reality. So I will discuss now the virtual reality, its architecture, how do we realize a virtual reality process, and then you will see, so what are the requirements for realizing this virtual reality applications. So as I say, virtual reality is a field of study that provides its user a synthetic experience to simulate and generate virtual experiences. And in a virtual reality, as I said, the user will be away from the real world. So a new reality will be created for the user by the help of this VR devices. So that's what the experience is, a synthetically generated experience, which is simulated on a computer environment. So here is a typical architecture of a VR system. In general, you can say this is the generic architecture of a VR system. So if you see into this picture, in this figure, so what are the major requirements you can understood from here? So we need to have an input processor. We need to have a simulation processor. There is a requirement for a rendering processor, and we should have a database with which all these processors should interact. Besides that, we need to provide at the input side the position and the orientations. And after the rendering part, we need to also incorporate some sensors and effects like the visual, auditory, haptic, or the touch. So this is all are the requirements for creating this a new reality by means of this VR devices. So the next question comes, then what is the role of this input processor, the simulation processor, the rendering processor, what exactly they do? So now to understood about this, so let me move on to the next slide. So here you can see the input processor, basically what it does. So it controls the devices used to input information to the computer. As I said already, when I said about the VR, I am planning to create a new reality, and that is visible by means of this computer simulation environment. So here you can see this input processor, what it does, it controls the devices that is being used to input information to the computer. The object here is to get the coordinates data to the rest of the system with minimal lag time. So here you can see, I use a term here, the lag time. So what is the significance of this lag time? So here we are trying to create a new reality system, which is not part of the physical world. So in this new reality or in the virtual reality, the requirement is that the lagging should be as minimal as possible. Otherwise, that synthetically generated experience for VR will be lost, or you will have a delayed response. Like we have seen that while a live event is going on, if there is a network lag is there, then you will not appreciate that particular part of the communication. So the same thing will occur over the VR domain also. Here, if the lagging is significant, then the virtual reality experience will be lost. So the requirement here is what? We need to design a system whereby we should able to incorporate the input informations along with the this coordinates to the system, rest of the system with a minimal lag. And for this, what we need, that keyboard, the mouse, the 3D position trackers, the voice recognition system, etc. These are a part of this input processor. Similarly, the second part I just shown as a simulation processor. This is basically the core of the virtual reality system. It takes the user inputs along with the task programmed for the world and determine the actions that will be takes place in the virtual world. You can say that this is the core of the simulation environment, whereby it takes the inputs and it determines the respective response or the actions to be displayed over the virtual reality or over the virtual world. Finally, the rendering process. This is very important. So in many times, because of the lack of proper rendering, you will feel that the virtual reality objects or the actions what is being created is not giving the feel of a real world, or you can say a real object. So the rendering part is very essential. So here you can see the rendering allows to create the sensation that are the output to the users. Separate rendering process need to be used for different kinds of activities like visual, auditory, the haptic, the touch, or any other kind of sensory systems. And each of this, the rendering will take, say, a description of the world, starts from the simulation process, or derive it directly from the database for each time steps. So if you see here, as I said, it is required that these processors need to interact continuously with the database. So this database may be a centralized database or it can be a local database, but it has to interact with every time steps so that the rendering and the simulation and the input process will occur in a synchronized manner. So in all these cases, the one thing what I didn't mention here is about the synchronous communications. And if there is no synchronization is lost, then you'll see your entire process will fail here. So the architecture gives us an idea that how we can realize a virtual reality applications by using a simulation environment. So what are the possibility with the VR? If you see, since this is a generic process, so we can apply this process or the principle into different aspect of our day-to-day activities. Like I can say, I can use this virtual reality for visualizing, for manipulating things that cannot be seen in the real world. Like you can see while we discuss about, say, some process, like I can say when I want to study about this biology. So if I want to explain the stem cells, how do I do? I need to take the students to a powerful microscope. I have to show them take the part of the stem and you can show the cells. But in a virtual reality scenario, I can create the same effect on a simulation environment, and the rendering process will help me in producing a exact replica of the real world scenario. This is one of the cases. Similarly, if somebody is explaining some manufacturing process, that also can be mimicked in the virtual reality, like a ship building process. It's a quite expensive and a tedious process to explain. So what we can do, we can create a virtual reality content by which we can explain the different steps in the shipbuilding process. Similarly, we can visualize 3D objects, 3D concepts, different objects in a 3D manner over this VR platforms. We can interact with the different objects in the virtual reality platform. We can explore the dangerous situations. Like as I said, if you want to simulate or if you want to have a experience of a nuclear reactor, or you can say like a war scenario, if you want to simulate those things. So that can be best done on a VR platform. So one more misconception is that people says VR, is it like a gaming? No, it is beyond gaming. So here what we do, so we add some additional degree of freedom onto the gaming applications. So the statement some people says that VR is a case of, or gaming is a VR applications. Okay, you can say that gaming is a sub case of a VR application, but it is not gaming referred to VR. Okay, so we have to put some additional degree of freedom there so that we can have the all features of the virtual reality. So you can simulate a different scenario situations using VR applications. Similarly, we can also have a realistic and a abstract scenario using this VR platform. Just 1 minute. Hello. Hello. Oh, madam. Madam, I'm in a, what do you say, this a talk. Right. I will call you. I'll call you back. Sorry. So now if you see, so this is what the different VR related possibility that we can realize. In the same manner, your augmented reality is one more aspect of this new advanced technology, whereby we need to augment, or you can say add on, the digital technology onto the real world. And for this, you don't have to use a very complicated setups. One can simply go with the smartphones, maybe with the tablets, or even with a PDS, we can create the augmented reality scenario. So now let me move on. So whereby I will say we are having a center of excellence in AR and VR, augmented reality and virtual reality. So you can see what the activities that we are onto this AR VR domain. So our this VARCO, that is the Virtual and Augmented Reality Center of Excellence, is basically providing different kinds of activities for in this AR VR domains. Like we are into this process of providing training and skilling development in the area of AR VR. So we are planning to offer this course, one course on AR VR, so as to create a human resource in the area of AR VR. Similarly, we are working on different projects for this teaching learning process implementation using AR VR. So you will see that in the next few slides, I will show some of the research activities that we are doing at IIT Bhubaneswar in this domain. Similarly, we are also planning to work towards the restoration of heritage structures using this AR VR platforms, and also to expand the reach of AR VR into this commercial aspects like this online shopping experience, how to improvise further the online shopping experience by incorporating this immersive visualizations. And finally, we are also working on this AR VR application for medical and healthcare area. So the different programs what our VARCO is supporting is like this pre-incubations, the incubations in the area of AR VR, the mentoring and expert supports from industry and academia for AR VR startups. Also, we are on this R&D activities on AR VR, IP creations, and the product developments. So we are shortly going to organize one startup onboarding program on AR/VR, and this is going to be held during 15 to 17 March. It also have a part on workshop whereby we have arranged some specialized talks on the area of AR/VR. So we have already made a curricula for this AR/VR program. So we are planning to offer this as a a full-fledged course to our student, as well as planning to offer as a certification course for the outsiders. So now, before I go towards the research activities, what we are doing, and some of the important results I show you in the area of AR/VR, I would just like to clarify one thing before I move there. What is the basic difference between this AR/VR? So we should not confuse. So as I said, when you say about the augmented reality, the requirement is that we are not leaving the real world. We are with the real world, but there we are augmenting the digital technology, or you can say we are overlaying the digital technology onto the real world, physical world. Whereas if you see the virtual reality, as I said, the user will be away from the real world. He or she will be in a new reality, what we call as a virtual reality, and that is a completely immersive environment. So in the augmented reality, you'll see the user maintains a sense of presence in the real world, whereas in your virtual reality, the user is under the control of the VR systems, like the sensors and the VR devices. So augmented reality requires a mechanism to combine the real world with the digital world, whereas your virtual reality needs a mechanism to feed the virtual world content to the user. This is what the major difference. Finally, you see the challenge in augmented reality is that it's very hard to register real and virtual world together. And in virtual reality, the problem is that, as I said, if you not have the proper rendering effects, if you not do proper rendering, and if you have a problem with the synchronous communication, you will see that your VR world is no more interesting. So the user will not have neither the patience nor the interest to be in this immersive environment. So this virtual reality, though, gives us a new reality, or you can say immersive environment, but the challenge here is more as compared to the augmented reality, in the sense that we need to have the proper mechanisms, all the three processes, as I mentioned: input process, simulation process, the rendering process, plus the synchronous communication. So these four aspects are highly required to a higher degree in your virtual reality. Otherwise, it will not be very difficult for making the virtual world a interesting place for the users. Fine. So now the other thing in this, both you consider about AR or VR, we need to have the display technologies for both. The display technology can be divided into two parts. One is the monitor based, other one is the head mounted displays. Monitor based, you can have different kinds of monitor based display technologies, like the laptops, the cell phone, the projectors. For the HMD, you can go with the video see-through or the optical see-through arrangements. So this is the display technology, and I would like to say here that, as you all of us are aware, that most of this display technologies till date are imported from abroad. Only few countries who are making this display technologies. But right now, with this Make in India initiative, so there are some companies who are trying to put a footmark in this visualization or in the display technologies in India also. So this is a very good opportunity to venture into this display technology, because most of the display technology, you name anything, you'll find that this is important. So this is a space where we can work on, so that we can have our own display technologies. And when you say about the monitor-based augmented reality, you will see that these are the simplest available units. You can consider your laptop, your PDAs, your cell phones, or even your tablets as a window through which we can see the AR world. As I say, in an AR world, there is no need to create a separate immersive environment. Rather, we have to integrate or add on a digital technology to the physical world, and this can be easily realized by using this, your PDA, cell phones, smartphones, or your tablets, or even laptops. The next was the optical see-through HMDs. So this HMDs comes with two categories. One is the optical see-through HMD, whereby you can see the graphic images only. So this is one of the stage of this HMD development. So whereby you can see here we have the graphic images which is being captured by a monitor. We have a head trackers, then it creates a sense, and finally it will be again fed via your this monitor to the eye, where we have a combination of the real world plus this digitally generated signal, which will be now merged and it will be fed to the end user. So we have an optical combiner that combines your the digitally generated info with the real world signals, and you can have the AR feeling. Similarly, the other part is the video see-through HMDs. So earlier one is a graphic image one, and this is for the video one. So here we need to have a video compositor. So again, we have the trackers, the video cameras instead of the graphic cameras or the images. We have here the video camera, we have the monitors, and video compositors will combine your real world videos with that of this generated synthesized videos, and finally it will feed to the end user. So this is how the video see-through HMD works. So the major players in the current AR/VR market, if you see, as I say, most of them are the imported ones. And to start with the Oculus Rift, the Microsoft HoloLens, the HTC Vives, the Vive Star, Bridge Star. These are some of the major PC-based platforms or the OEMs who are producing the items in the PC platforms. Similarly, for the mobile platform, it is the Google Cardboard, the Samsung Gears, the Metal View Masters, and the G's VR1. So these are some of the OEMs who are onto this AR/VR products. So this is a very good market. So people should take up activities in designing this display technologies, which can be used for this AR/VR applications. So this is our laboratories, what we are having in our IIT Bhubaneswar. So we are working on the different aspect of this AR/VR. So this I'll leave it now. Let me go to the ongoing research and development activities. So we are currently running 9 projects in our this center. All are the in-house projects. So some are basically for the classroom teaching learning process, and some are for the autonomous driving process realization using AR/VR, what we call as the intelligent autonomous car. We also have a project on this NDT, non-destructive testing for lifetime production of oil, natural gas, and steel industries. Similarly, we have a VR and AR module for training of the metallurgical and material engineering students. So, and finally, you can see a few more projects are here listed, like the augmented reality based guided poetry. So here you type a few words, the system will generate a few more sentence, as well as your the scene will be generated for your words. So by that way, one can complete a poetry. Similarly, we have a sensor-based application for the AR/VR, what we call as the augmented reality-based way in motion sensor. Similarly, we have the project on this robotics controller, industrial robot controller, that is a manipulator designs and integration with the AR/VR platform. Similarly, the composite machine learning scheme to detect your lung cancer and VR-based augmentation for better diagnosis. This is in the area of healthcare. Similarly, we have one more project on this virtual reality application for your smart grid visualizations. So these are some of the activities that is going on in our center. And here I can show you some demos. So here, some of the AR/VR interaction with the, or you can say the interactive environments, whereby the a course, part of the course has been designed here. So this is a part for the data structure. So you can see here that the user can interact with the different shapes and creates a what do you say, tree structures and so on. Similarly, here a experiment, chemistry based experiments, whereby you can see the when the user is adding some chemicals, you can create a VR scenario here. So you have to augment here the different kinds of sensory system, as I say, the rendering process, whereby you can add on the rendering sensors, and by that we can generate the different what do you say, feelings there, or you can say different experience, synthetically generated experiences. Similarly, this is for the visualization of plane and the directions. So here also, I think the video is here. You can see the different plane, how to explain the planes of a cubic crystals, like a 111 planes, and this is for 1-to-1 plane. So this all can be realized using your this AR VR applications. Similarly, we have one more project on this, how to control the manipulators using AR VR applications. So here you can see by giving the command from a tracker, so we can control the movement of this manipulator's arms. So this is the way, so this AR VR can be explored into different applications, different engineering applications. So I didn't show any, what do you say, aspect in this heritage and cultural applications. So this can also be expanded into this heritage reconstruction activities. This is one of the sensor-based way in motion application, whereby the visualization part is based on your AR VR. Similarly, this is again a wearable sensor where we are planning is to apply this AR VR there. And this is the what do you say, the story to screen generation case. So by you write something, it will show you some screens. So it's a kind of mapping, you can say AR VR based mapping. Similarly, this is one more scenario, the NDT, the non-destructive testing of the scheme of the industrial processes. So here the AR VR being used as a visualization unit to identify the defects and the faults, and it can be quite useful in providing the monitoring and the maintenance services, and thereby avoiding the, you say, this downtimes. Similarly, this is one more aspect where the AR VR being explored for the healthcare applications. The different problems what this team is addressing is on this COVID's, cancer identifications, and also for the other infectious disease case. They're planning to implement a model using AR VR. This is the other projects based on this AR-enabled remote driving station with synthetically intelligent autonomous car. Here you can see this car is being designed and now is autonomous driving car. Here the visualizations and the control mechanisms are realized using your this AR VR applications. So you can see this is the driving station in the laboratory what we generated. So, and this is the on-field testing time, and this is inside the car, but it is a remotely driven vehicle. So the vehicle is being controlled by this user. And this is what the different possibility with AR VR, different areas where you can apply this AR VR technology. So because of time constraint, I didn't mention many of the applications, but it is having a lot of possibility. So I can say that in conclusion, this VR and AR platforms are ideally suitable for wide variety of applications. And as I said, so we can also have a mixed reality along with this AR and VR. So in VR, as we seen, in case of VR, what we seen that we need to create an immersive environment which is away from the physical world. So it is basically a computer simulated environment where the rendering process need to be very strong. Otherwise, the users will lose the interest for this virtual world. Whereas in the augmented part, we have seen that we are overlaying a digital technology onto the physical world. So we don't need a very high-end setup for preparing this AR applications. Rather, we can go with the available smartphones, your PDS or tablets, or even using the laptops. You can create this AR applications. And this application areas are there are a number of areas are there where you can apply this AR, VR, and we can brings the extra degree of freedom for the users. There are some cases are there where the training and skilling is very costly affair and also very dangerous. So AR, VR can be exploited into those areas to provide the skilling training as well as not only for the skilling training, but also for the simulations. Like you can say, I want to learn this flight, what do you say, this driving of the trucks or the driving of the tractors, or even you can say the driving of the train engines. So all this can be done using your this AR, VR applications. It can be expanded into this music and fine art area. I just shown one of the applications whereby we can create the poetry from the help of your this AR, VRs, whereby the user can create not only the words, but also the scenes associated with the words. Similarly, this can also be applied for teaching learning process of not only the engineering subjects, but also for history and the geography subjects. Similarly, we can design different kinds of simulators, like I given the example of the driving simulator. Similarly, one can also design a medical simulator and so on. This AR, VR can be used for improving the performance in the sports and the athletic area, like by providing the sports and athletic training using AR, VR. Similarly, it can also be used in the medical fields for providing the training. So because many of the time it is found that difficult to provide the different kinds of training to the medical students. So this AR, VR based application may be used as a complement to the training of this medical students. So it has got a lot of scope. Okay, so with this, I'll conclude. Thank you. If you have any queries, I'll be happy to answer. Thank you.
Thank you, sir. Thank you for the wonderful presentation and giving us a walkthrough of your research, not just your research, but also the latest developments in AI, VR. I think most people just think that it is limited to games and limited to gaming and a few educational tools, but you gave a complete overview of all of the applicable areas, how it is being used in healthcare, how it is being used for development of self-driving cars, for teaching and education, for skill development. And my favorite was also about oil and gas, industrial processes, and so on and so forth. Sir, there is one question, if you can take it. Sir, we know that AI, AR, VR is being popularly used in gaming, but you also mentioned about the applications of augmented reality in sports and athletic training. Sir,
Right.
so if you could shed some light on that.
Basically, when you say about this sports facilities for this athletes and the sportsmen, so many of the countries, they are not equipped with all the requirements. So in that scenario, we can create this virtual environment whereby the sportsmen or the athletes can have a feeling of the real stadiums, or you can say the real field scenarios. So they can have a feel of the tracks, or you can say feel of the stadiums, and their performance can be improved. Like suppose for the cricket scenario. So if you want to provide this bowling or a betting training, so that can be achieved using this VR, AR applications, mostly by VR applications.
Thank you, sir.
Thank you.
There is one question in the chat box, but I think you've already answered this. That has this technology been applied or researched in the medical
Medical field,
field?
yeah, right. It is already being applied, but not in large scale. So people are trying for this to popularize this on a mass scale. So one of the cases that your this painless needles. So for that, people are working on that. And besides that, some kind of this sonography and other areas, there also people are planning for this AR VR based screening and for the testings. But about the surgeries, it is not yet started. As I said, for the training, it is possible, but not for the real-time surgery. Whether people are training the student, medical student, on surgery subjects. But till now, the AR is not exploited for a real-time surgery application.
Thank you, sir. So there is one last question from my end. You mentioned about a project where you're working on detection of lung cancer using ML techniques.
Correct.
Sir, so if you just could give an overview of it, or
Basically, this is one of our Professor Kishore Sahu. He is the PI for this project. So he is working on this lung cancer identification at the early stage by using this machine learning. So they had collected a huge amount of data. They are using this deep net technique for identification of the early stage of the cancer, and as well as they are integrating the visualizations by means of this VR, so as to create a display system whereby the doctors can immediately identify the early stage of the cancers.
okay, sir. Thank you, sir. So there is one last question that how close we are to implement AR VR tech in our military.
As I said in my very first slide, this AR VR concept started with military. So already it is in widely used abroad for training the soldiers, or you can say the military personals using AR VR technology. The starting is because of this military application only. So, but in Indian context, it is not much popular, but I hope in the next few years, the Indian system also will adapt to this technology for military trainings. But it's already in use. It's already in use, and its starting point is the military only, military applications.
Thank you, sir. Thank you again for sparing time for giving us this lecture and sharing with young minds regarding. No, there are no more questions. I thought there's one more question popped up. So thank you, sir, again for spending your time and sharing your insights, giving the complete overview of AR VR just from a layman's perspective, and so that everyone can understand, demystifying it and making it easy for the audience. And the audience are mostly school students and college students. We are streaming this session on YouTube as well. So anyone who wants to rewatch it or share it with friends or family can share it. Thank you, sir, again for
Thank you,
this
ma'am.
session.
Thank you, ma'am. And thanks to all the participants, and also to Sri Prasad Singh ji and to Lakshmindar Padiji. Thank you. Thank you all. Bye.
Thank
Bye
you,
and
sir.
good day. Bye. So I log out now. Thank you.
Okay, thanks. To the participants, thank you for being patient and being with us. For the next session, we will begin at after 10 minutes at 4:30 p.m. Thank you. Hi, ma'am. So we'll be currently, I think we'll join, we'll restart. Yes, hi, ma'am. Uh, Good evening. So we'll be restarting this session in another 5 minutes.
Sure.
Okay, thank you. Hi, ma'am. Can we start the session? Yes, ma'am. It is. Your screen is visible and it's in full screen, but I think I am not able to. There's no audio. Maybe.
Can you hear me?
Yes, yes. I'm
Yeah.
perfectly able to hear you.
Okay.
Okay. Mm. Okay,
So
ma'am.
can we begin now?
Yes, ma'am. So, welcome back, everyone, to today. For the last session is by uh, Dr. Lipika Sahu on the key innovations that made a mark in India's development story. I would also like to take the opportunity to give a brief history, brief bio of ma'am. So, Dr. Lipika Sahu is a registered patent agent and trademarks agent with 16 years of experience in academia and industry in the areas of technology, innovation, and intellectual property. She holds a PhD from IIC Bangalore. She also holds a triple master's, a master in science, a PG diploma in IP rights, and in law from National Law School of India University, Bangalore, and also a PG in business management from XIMB. She also holds an advanced certification degree from World Intellectual Property Organization, WIPO, World Academy in Patents and Patent Drafting. Prior to Life Intellect, she worked with multinational companies and law firms. She has a rich experience in patent drafting, patent office actions, and IP analytics. Sorry, I missed out the point that ma'am is currently the founder and CEO of Life Intellect Consultancy Private Limited, which is the headquarters of which are in Bangalore. Her specialities include biomedical science, drug discovery, development, product development, pharmaceuticals, healthcare, life sciences, intellectual property, IP analytics, patents, drafting, business development, branding, strategic management, and consultancy that have been developed over the years by working with scientists, researchers, industries, and academia across the globe. Thank you, ma'am, for joining us for today's session. Over to you.
Yeah. Thank you, Kalyani. And thanks to Government of Odisha Science and Technology Department and KIT DBI and KIT University and Odisha Vigyan Academy Regional Science Center for making me part of this 1 week long science festival. So today in this 1 hour, 45 minutes, 1 hour, we are going to talk about different key innovations that made a mark in India's development story. So ସମସ୍ତଙ୍କୁ ନମସ୍କାର. If anybody wants to ask any question in ଓଡ଼ିଆରେ ବି ପଚାରି ପାରିବେ. If you want to elaborate something, you can stop me and we can have the question answer, elaborate question answer session towards the end. Now,
sorry to interrupt. Actually, session ta ame YouTube re stream karchu. So this will be from your side. Jodi jetiki participants achanti ya mate jodi YouTube ru kichi questions asibo mu apan
you can ask.
Ha mu forward kar debi. Okay.
Or you can help me in sharing those questions and announcing, and I can answer.
Yes, yes, definitely.
Yes. Okay. So if we talk about India's great inventions, India is one of the oldest civilizations in the world, and it has a rich history, culture with a strong and long scientific and technology tradition. So there are a lot of domain that Indians have very strong in kinds of technology related to dentistry, Ayurveda, diamond mining, plastic surgery, architecture, astronomy, cartography, metallurgy, logic, mathematics, and meteorology. So as we see the different kinds of invention, and these are the different domains of innovation that Indians have made. First, let's just understand what you understand by innovation and invention. So if we have to explain invention, invention is something you create for the first time, or something new product or new process uh, which is not known earlier. So that is called invention. Whereas when we talk about innovation, innovation maybe the technology might be existing, the product or process might be existing, but you make changes, take this product idea or process idea to the market and practically implement it. So this is how the main difference between invention and innovation. Invention is basically made with a research or scientific method, and it should have some technology advancement over what is already known. And the another important criteria for invention is it has to be non-obvious, means the same idea should not come is not known to others. And basically it is for one single product or process. And then if you have some invention, you can file for a patent, you can get some IP protection for that idea, and you need scientific skills to develop that invention. Whereas in case of innovation, it's basically you have the idea and you are making it a reality, and it's basically you add some value to this product and process that fulfills a certain requirement of a customer. It can be combination of many ideas. No, unlike invention, it has to be patent is granted for one particular idea. And for this, you need several different kinds of skills, like you might have a scientific skills, then you might need marketing skill, technological skill, strategic skill, all these required to make one innovation successful. So, for example, like when the wheel was invented for the first time, that was an invention. And when the motor car came for the first time, it was an innovation. Means there are so many different kind of ideas was there in case of a motor car. Like you have a wheel, you have a machine, and you have steering. So many things put together into one processes that leads to an innovation. So basically, when we're talking about key innovations in Indian growth story, we'll be looking at quite a few important ones. So initially, I would like to begin with few traditional way how Indians are good at innovating. So if you see, first is zero, and that I think many of you would be knowing that. So zero is the biggest gift of Indians to the world, because without zero, there would not have been no mathematics, no addition, subtraction, or no computer. That is one of the important one. And then next is wireless technology. Though the historian credits Guillermo Marconi for inventing wireless radio communication, but Sir Jagdish Chandra Bose, before 2 years before it was actually published by 1985, before 2 years before Marconi gave his demo in England, Jagdish Chandra Bose has demonstrated the similar technology in India. Other than that, Indians have the credit to invent a lot of different kinds of board games. Then we also have, you say, cataract surgeries and nose implantation. That's called different kind of nose-related surgery was already demonstrated by using a curved needle. So by Sushruta, he has written Sushruta Sahita, and who is the father of Indian medicine that we say. And all these details you can find in find in all this literature, well documented in US. Different universities, they give credit to Sushruta as one of the ancient father of medicine. And then we have Ayurveda. Ayurveda has a lot of formulation to treat our people by using the Ayurvedic formulations. And right now you see lot of this patent that we are filing by pharmaceutical company, by multinational company, they in fact goes back to different kind of Ayurvedic text to understand the medicinal property, they validate and they file for a patent. So a lot of this knowledge is that our Ayurvedic tradition has lot of benefit to the world currently. So these are some few 5 to 6 key innovation that Indian have been contributed to the world. Now, with that background, let's understand at present, after the independence, what are the key technology development that has happened, that has helped India in this growth story. So I would like you to listen to this conversation. Okay.
Ma'am, it is not audible.
Okay, so I'll just tell, it was a simple iconic conversation that happened on 4th April 1984. That was the first time in the history that was an Indian was in space. He was the squadron leader, Rakesh Sharma, and he was describing his experience to Mrs. Indira Gandhi, the Prime Minister of India, and then the Prime Minister of India, that ऊपर से भारत आपको कैसा दिखता है? And squadron leader Rakesh Sharma is saying, "Sare jahan se acha." So this was an unbelievable moment, and this reply of squadron leader Sharma's was legendary. And India's space research program was formally begun in 1957, barely 1 decade after our independence. So it was even difficult to think about talking or launching a space program at that time because it was far too expensive, and India was trying to develop. It was in development mode because after the independence, it was very important to and basic education to our people. That was the question that Indians were asking. Should India be thinking about doing this risky exploration to the space? But thanks to 2 amazing, audacious scientists, Homi Bhabha and Vikram Sarabhai, and later the space program was taken forward by Satish Dhawan. That time they convinced the government that the space program will help Indian farmers, Indian defense system, and weather, communication, lot of things. That's how the Indian space program was started. And that time we had no resource, no expertise, no training in space technology. And you see one spacing village was, they become the site of the space launch. And you can see this first rocket was being carried on in a bicycle. So that was the beginning of Indian space program. And within few decades, we managed to build our own satellite launching vehicles. And today, India occupies a prestigious spot in small list of countries that consider themselves an elite space club. So space program has helped India in a lot of modernization. Now I would like you to play, I'd like to see this video.
Ma'am, there is no audio from your end. Is that?
Oh, you can't see any audio here? You can't hear any audio here?
I can't hear the audio from the video. Dhruti, just can you confirm? Are you able to hear it?
No, ma'am.
Is it audible? Is the video audible?
No, ma'am. The audio is not coming.
Okay. So this was a speech by APJ Abdul Kalam. He was describing SLV3 launch. He was a mission director for SLV3, and he was saying that it was in 1975 they started this program, and 1975 Aryabhatta was first satellite was launched from Russian station to the space. That was the beginning of satellite launch program by Indian Space Center. And then this program is Abdul Kalam is explaining SLV3 project. He was the project director, mission director. And the first project was a failed mission, but within 1 year, they bounced back and they started off with a lot of this SLV3, ASLV, PSLV, and GSLV, all these different kinds of satellite launch program. And that has helped India into different kinds of technology. And I had the honor of listening to Dr. APJ Abdul Kalam. That time I was a student in Indian Institute of Science, and he was the president of India. He described how from a humble beginning, our space technology went on, and we were able to do a lot of lot of activities through the space research program. Like, for example, it has in military, lot of application of this space program in military. Our space programs have helped our defense system to give exact accuracy of the movement of our borders and how they can protect our borders with the help of space technology. Then there are telemedicine. ISRO has applied this technology into telemedicine, where you can, a patient can, in the rural India, can talk to the medical professional from the city, where the doctor cannot go regularly to the villages. In biodiversity information, like ISRO has helped implementing this biodiversity information system. What happens, what happens to our green cover in different areas, say Western Ghat, Western Himalayan, Andaman Nicobar, all this has been implemented and helped to maintain our biodiversity with the space program. There are a lot of international cooperation because of the ISRO, which these countries are put together. They are helping each other. India is helping so many other countries. Taiwan recently, we launched one satellite for them. So these are the international cooperation having because of our space program. So this is some of the ISRO space program success, starting with Aryabhatta. Then ISRO has the world largest constellation and remote sensing satellite. It has sent 2 missions, one to Moon, one to Mars. And this GSAT navigation Indian constellation system as helping our defense personnel to protect our borders. These are the different things that ISRO is helping. So I would like to say that ISRO space program has been helping India's growth story in different kinds of segments. Now, after the ISRO, let's move to another from space to Earth. Here, let's talk about Green Revolution. And what we call father of Indian Green Revolution is MS Swaminathan. That time, immediately after our independence, we were resource poor country. We had to depend on other country for rice, for wheat. Then MS Swaminathan, he started this Green Revolution. Different kinds of technology, different kinds of improved seed were used for the wheat, rice, then jowar, bajra, maize. And within couple of years, like 67, 68 to 77, 78, within 10 years, India has changed its status from food deficient country to one of the world's leading agriculture nation. That happens because of the Green Revolution and because of the steps taken towards the development of the agriculture sector. And because of the Green Revolution, you see, we started, instead of importing, started exporting the food, and the income level of the farmer was also raised. A lot of industrial growth happened in case of say tractor, harvester, thresher, combines, which the equipments used in the agriculture. A lot of these agro-based industries were also flourished because many of this industry, they use raw materials, waste raw materials produced by this agriculture. Then rural employment also increased. So all these things happened because of our green revolution, using different kinds of seeds, equipments in the agriculture sector. Next, we'll talk about information technology. India's first IT industry was born in Mumbai in 1967 with the help of this company and a collaboration between Tata and one more company. So that started in 1967, and the partnership started in 1977. From there, the IT sector has seen boom in the growth of Indian industry. You see from 2008 to 2020 onwards, towards 2019-20, that is a steady growth of Indian IT sector. And Indian IT sector is a backbone of our country. Like there is a lot of facilities by the government to set up IP companies, IP farm. There are sort of special economic zone. A lot of foreign investment is coming to the IT sector. And so this sector, if you see, there are $180 billion in 1920 with export revenues of $99 billion. So for India's GDP, the growth from the IT sector is immense, and it has helped a lot of other technologies like you can see IT, ITS. It employs one of the major employment to our Indians workforce is the IT sector. Now here you can see the projection is by 2026, our IT sector would hit 350 billions, and it empowers 2 lakhs women and 15.5% growth year on year. So this is some story of our Indian IT sector, which has played a very important role in our growth of India. And also because of this technology, there are a lot of IT and healthcare. A lot of these healthcare services are enabled with IT technology, wherein we can provide the healthcare to rural India due to this IT and ITA services. Next comes one very interesting story about COVID and COVID vaccination. As you know, COVID is an infectious virus. It spreads through cough, sneeze, and when you are infected and you are with short range with the infected person, you get this infection very easily. And it was important for us to vaccinate all our people to prevent this disease, and it was the biggest challenge for us. And in October 21st, we crossed 1 billion, like 100 crore vaccination in India. It is one of the world largest vaccination drive. So when it was started, people were skeptical about whether India will be able to deliver, whether India able to do this. But there are 180 countries who are still trying to procure vaccine, try to vaccinate their people. And imagine if we do not have our own vaccine. And the credit should be given to, say, Indian scientists and entrepreneurs, which has helped India to achieve this milestone of more than 1 crore vaccination has happened. And if you see, more than 75% of Indian adult population have received at least 1 dose, and nine states and union territories have administered first dose to all its eligible people for the vaccination. And there are 7 Indian companies, they are working on this vaccination program. Serum Institute, Bharat Biotech, Reddy's Laboratory, Chiters Biological, Genova Pharma, and Panacea. And you know, to make one vaccine successful, usually it takes 5 to 10 years time. But during this time, because it was so emergency that we had to make this vaccine work and to vaccinate our people. So within few months, within 6 months of initiating the program, we had a successful vaccine and we could immunize our people more than 130 crore of vaccine jabs we have given. So this is not a simple story. This is because I personally, I come from a biology research background. I know how difficult it is to make a successful vaccine and make it work with the people with equal amount of efficacy, that you don't get spread the infection easily to other people. And recently, last week itself, the Covaxin, our Indian vaccine from Bharat Biotech, has been approved by US FDA, and where they are contemplating to give this vaccine to less than 12 years old population. Next is India is known as pharmacy of the world, and we have exported different medicine and medical equipments to more than 150 countries, and more than 65 million doses of COVID vaccine also to more than 100 countries we have exported just last year. So how it was possible? Basically, if you, I would like to take back into history around 1980. Before that, there was no protection for any live microorganism or any kind of biotech kind of research. That's why you will not see a lot of investment coming into biotech or healthcare sector. It was in 1980. There was a very important case laws which happened in US, where Chakrabarti, who was an Indian scientist working in GE, he applied for a protection, patent protection for one of his idea, which he wanted to claim one oil-eating bacteria. And that time, any live organism was not allowed for any patent grant. And this case went off to US Supreme Court, wherein finally the court says, if you have a microorganism where you have genetic engineered some new gene, that is patentable. Not naturally occurring one is not patentable, but this is patentable. And that was the time, 1980, where there was a boom of investment started in healthcare and life sciences sector, because companies and people realized that even if they have a live microorganism or gene or say protein molecule that can be patented, and they can get that benefit out of that patent protection. So that was the time. Following after that, lot of boom in healthcare and biotech sector you see. And till 2005 in India, we had no product patent available. So what used to happen, we used to make lot of generic drug having different products, and these drugs were almost 99% cheaper than what is available in Western market. So that has helped flourish Indian pharma industry, and that's how we could sell this product, this medicine, to different country with lot lesser price. That was one of the reason. But after 2005, we have this product patent, product claim available in India, because India became treaty to global TRIPS agreement. So where we have to have both product and process patent. And after that, lot of these multinational companies started doing research and set up that R&D center, because they realized that India also can give product patent claim. That is one part. Second is we have a lot of skilled manpower in case of say biotech or healthcare sector. Third is we have the technology and we have the skilled people to manufacture these drugs and export it to foreign countries. So that's why India is called as the pharmacy of the world. The next is entrepreneurship. If I would like to say, our MSME, medium small business sectors is 40%, contribute to 40% export. And out of this, we have 90% people in India who are self-employed or work in some informal sector. If you see India's demography, means average population age group of India, which is almost one of the youngest in the world. And it will continue. Now, currently, it is less than 25 years, is the average Indian age of India, and it will continue. Demographic dividend will be continued for the benefit of India up to 2025. So that is a lot of advantage for India to to have this strong, young entrepreneurial system, which will help in setting up new companies, different companies, and our workforce is young to make all this innovation, all this technology that we have been talking about. They can make use of it, and we have a lot of positive days going forward where we make use of all these technologies. And because of that, you see our Indian startup ecosystem is booming in India, and India is an emerging market. People have the purchasing power to buy different kinds of products. And when a bigger company or multinational company comes to India, their product, for you have in India different age group of people to buy their product, test their product, and the growth is more here. And there are a lot of government support by Make in India initiative to support this entrepreneurs, support these startups in the growth of India's story. Recently, Indian government has allowed all the startups who they are filing patents and a lot of other benefits, their patents to be expedited. If you are just a regular company or individual, you will not have the option to expedite your patent application. A lot more benefit are coming from the government to the startups, to entrepreneurs, to the innovators. Now, students like you who are having some sort of inclination to solve a problem, and where you can put up hard work and perseverance, it is very easy, and it is required for the young population not to just look for a job, but look for creating job for others. In turn, you are trying to solve a problem. When there is a problem to be solved, there is an entrepreneurial skill is there to take it forward. So, and India is at the right place, having a young population, having set up all this technological advancement, lot of programs for the government, which is helping the India in its growth story. Okay, so with all this background, I'll talk a little bit about intellectual property, because when you start a company, when you have all this innovation that you saw, and all this innovation, when you take this idea forward to market, and you can file protect this idea through different aspect of intellectual property rights. These IP rights are typically like the regular property rights, like you can buy it, you can sell it, you can lease it. Earlier, it used to be industrial airs or electronics airs. Then later, in late 90s, it is IT and biotech airs. If you see in 21st century, the leadership would be in the hand of people who create or harness knowledge. Right now, if it is the core of modern economy is knowledge-based economy, and if you see the more than 85% of 100 best companies, they have their property, which is more than 85% of their property is intangible asset. Intangible asset means it is in form of, say, patents, trademarks, copyrights, or design. So these are the things that people create, the companies create, and more than 80% of their asset is in form of IP rights. Now, why IPs, intellectual property right, are important for countries? Because it will help you to create asset. It will help you to build the brand of your company, of your country. Right now, earlier it used to be US where more number of patents was filed. Right now it is China, and India is also coming number 6 in this patent filing, number of patent filing in the country. Because of filing patent, you can license your product, you can get your bargaining power in the market, and it is a tool to promote your business and to get your loyal customer. So when you have this interesting idea that can solve a problem, you protect that idea through IP rights, file a patent or trademark copyrights, and then these ideas will give you all these benefits when you have this IP. When you are owner of an IP, it will give. And from India, if you want to have international patent protection, there's a different route that you can file international application where you can protect your idea in many different countries of the world. So Initially, when you have the idea, you do a research and then you develop a technology, then you have a product or process, and then you take that product and process out to the market. So when you start with this idea, you sign one confidential agreement with the person when you are disclosing your idea, because that would help you to file for a patent and protect your idea. So having an idea is important, but how you should protect that idea, that is also more important, because when you want to take this idea to a market, you need to have some exclusivity or you need to have some ownership for this idea. Then when you develop this technology, you file, say, patents, and then finally when your product is ready, you transfer this product or technology by a technology licensing agreement to other company who can take this idea forward, or you yourself can set up this company and take this idea forward to the market. Okay, so as we discussed, so this was the brief technology that we discussed, which have played an important role in India's growth story. We talk about ISRO to Green Revolution, and then we talk about IT sector, how it has plays a major role in India. Then after that, it was our vaccination program, the pharmacy, or the pharmaceutical industry, how it is making an important contribution for our healthcare and growth, and it is also able to export our pharma components to pharma product to other country as well. Then after that, it is the young demographic, young population of India, which is venturing into different kind of entrepreneur journey, and that's how we are able to make different kind of small economic cluster, and these companies are taking the different kind of ideas product out to market. Now in 2014, our Prime Minister Narendra Modi has made this idea of Make in India initiative. The idea was to improve focus on the manufacturing capacity of the country, because right now we are more into a service-oriented economy, where our IT or ITES sector is more of a service economy. And now if you want to grow in the growth curve of the company, you have to have good manufacturing capacity, which through this Make in India initiative, the target was to grow the GDP of our country from 16% to 25% and create 100 million jobs. And special focus was given to automobile, defense equipments, medical devices. So that would help us to cut down our imports and we can become self-sufficient like Atmanirbhar Bharat. So with this background, I think I can end the talk. If any of you would like to ask any question, I would like to take it.
Thank you, ma'am. Thank you for the wonderful presentation and giving an entire overview of everything. Covered a lot of topics, right, from what is technology, what is innovation, because I think many people, sorry, what is invention and what is innovation. So I think many people it can be used interchangeably. So especially for young students, young minds, it's a very important topic to start with. Going forward, I would like to request if the audience, if they have any question, they can either drop in the chat box or they could send it across or unmute themselves and ask the question.
Hello, ma'am. This is Smita here.
Yeah. Go ahead.
Ma'am, I just had one, it's a query or not even a query, but a concern that India still now doesn't allow patent with respect to softwares. So yeah, I have an understanding that when the software is novel and the hardware is novel, there is a go ahead with in terms of patentability. What is your say in that? Like, shouldn't this be the high time for India to allow software patents?
See, no country in the world, they allow software patent. It is not only India, because it is very easy to write a software even without implementing it. that to get a patent claim for that. Okay, if it is say hardware or manufacturing sector, you have to make it, or you have to really show how you can enable the implementation of that hardware, then only you get a patent. But in case of software, if we just allow the software code to be patentable, then what happens is everybody would just, without developing the product, they can just write different codes and get the patent. Do you think it is good for the development of software sector? Because if one company filed one idea by developing some code, and it stopped all other company working on that same kind of software product, right? So that is why it is not allowed, neither in India, not in US, no other country. They don't, software code per se is not patentable. Like your patent claim cannot say that you have this code which is patentable. But if your software is having some sort of novel steps, or it has some hardware component, that is patentable.
Okay, ma'am. Thank you.
Thank you, ma'am. Thank you for the wonderful presentation. I would like to thank you for spending your time, valuable time, and sharing your insights and encouraging young minds and motivating them to explore new dimensions and think out of the box, and giving them an overview of the patenting world. Still many are not do not give us such a demystifying it, making it simple how to understand. This video is also being live streamed in YouTube, and if anyone wants to rewatch, or if they want to forward it to friends and family who are working in the domain or would like to learn on the domain, please feel free to share, or please feel free to contact me and I'll share the link with you. Thank you, ma'am.
Thank you so much.
Thank you, everyone. Thank you, everyone who has joined us for today's session. I hope you had an enriching session and full of learning, full of motivation, full of insights, knowledge, expertise from all of the subject matter experts who joined us throughout the day. And we had 5 sessions. It was a lot, but I think there was something to learn from each and every session. Thank you again. Have a nice day. Thank you, ma'am. Hope you
Yeah,
happy.
bye-bye. Bye-bye.
Bye-bye.